This is a stepper motor controlled by an ESP32 microcontroller. It's part of a low-cost ventilator prototype that I'm working on. And I just want to talk about the motion control aspect and what that looks like on the ESP32. So you can break it up into a couple different steps or thoughts. One of them, probably at the basic level, you need a timer that can accurately and repeatably step the motor at the right frequency. So the first thing that you need to interact with is the Esp Timer Api. Now I'm using the Arduino version of the Timer API. It's like an Arduino wrapper around the ESP IDF toolkit, and it's fairly straightforward. You begin the timer begin command allows you to specify a prescaler, and then you can attach an interrupt and have that interrupt fire every certain number of clock cycles. If you've worked with microcontrollers before, all that information is pretty standard across any microcontroller. Alright, so once you have a timer set up for a fixed frequency, then what you can do is use a Bressingham line tracer to cause the stepper motor to tick at a certain fraction of the timer frequency. So if the timer frequency is 10,000 hertz, you can use the Bressingham line tracer to make it tick exactly 1,000 hertz. And then you can use a second Bressingham line tracer to ramp up the speed of the first line tracer to using a certain acceleration value. And let me show you what that ISR, or the interrupt routine, looks like. It's broken into 3 steps. This is a trapezoidal acceleration profile, which means the velocity starts at 0 and then in a linear fashion it increases to the maximum velocity, and then it cruises, and then it ramps down. So you have 3 steps. The first case is your step counter is less than the ramp up distance. The second case is you're after the ramp up distance but not yet to the ramp down, and then the third case is the ramp down. You can see in the ramp up and in the ramp down, I'm using a Bressingham line tracer, and the way that works is for every, say, 10,000 times this code runs, the .next method will only return true 1,000 times at equally spaced intervals. And of course I use 1,000 as an example. So it will ramp up the speed of the second line tracer, which is the actual speed of the motor. And then the last thing that you do is step the motor. So I'm not actually sure how common this Bressingham line tracer, or if there's a name for that type of algorithm, but I found that it works. It's extremely fast, because one of the keys to doing this is having integer-only math in your interrupt service routine. Actually, you can't use floating points during the interrupt service routine on the ESP32 will actually crash the CPU. So, but generally speaking, those operations, floating point operations, are slower. Alright, now in order to know when to ramp up and ramp down, that can be calculated separately. So I created a trapezoid class, and you provide it with the distance you want to go, the acceleration that your system can handle, and then your three velocities: the entry velocity, the cruise velocity, and the exit velocity. And then it'll calculate how many steps into it you need to stop ramping up, and when you need to start ramping down. So I think these calculations are probably pretty standard or something. And that is about it. So hopefully you understood. The most complicated to understand part would be the Bresenham line tracers. But I guess the alternate method would be, rather than a fixed frequency timer, you would be changing the frequency of the timer, and then you would match the frequency of the timer to the frequency of the motor. That's the way some of the, like Marlin open source 3D printer driver or firmware does that. Anyway, that's hopefully it's an approach. We're working pretty well.